Alright class, so before we get into chapter 3, what we're going to do first is we're going to go over a little bit of a review to kind of get you in the mood for chapter 3. Stuff you should already know coming into chapter 3, stuff you should know really coming into this class, but maybe you forgot it, need a little brush up on it, need to be reminded of it. So first thing, properties of exponents. Okay, so if you've got the same number multiplied and that number has exponents on either of them. So you got a to the m times a to the n. You can simplify that by saying that's the same thing as a to the m plus n. What that means is if I've got a 5 here, 5 squared times 5, say to the 6th, is the same thing as 5 to the 2 plus 6, which is the same thing as 5 to the 8th. Just a general quick example there. Okay, and if you're dividing here, so you have the same number, 5 or a to the m over a to the n, you can rewrite that as a to the m over n, or n minus n. Alright, so same thing, I'll use a 3 this time. So if I've got 3 squared over, I don't know, 3 to the first, that's the same thing as 3 to the 2 minus 1, which is the same thing as 3 to the first, which is obviously the same thing as 3. Alright, so remember your exponent properties. Alright, other exponent properties you kind of need to know. A to the 0 is 1, so anything raised to 0 is 1. A to the negative 1 is the same thing as 1 over a. A to the negative n is the same thing as 1 over a to the n. This is the one that I see people trip up on a little bit. So here, if you've got, say, 6 to the negative 2, you can rewrite that as 1 over 6 squared. And you can also go the other direction. If I give you 1 over 6 squared, you can rewrite that 6 to the negative 2. That'll be helpful when we get to the exponential and logarithmic stuff as well, so keep that in the back of your mind. Alright, and the fourth property, a over b raised to the negative n is the same thing as b over a to the n. So here, you've got two different numbers, so we'll say 6 over, I don't know, 8. I know that's not a simplified fraction, but just throwing random numbers out here, to the negative 3. You could rewrite that as 8 over 6, all raised to the third. And what you could actually do if you wanted to, an additional part, if you wanted to, you could actually rewrite that also as 8 to the third over 6 to the third. Okay, so not the same part of that property, but throwing it out there too as a little refresher. Alright, rational exponents. If a is a real number, variable, or algebraic expression, and n is a positive integer with n greater than or equal to 2, and a raised to the 1 over n equals the nth root of a, provided that the nth root of a exists. Okay, so essentially, if I've got a number raised to 1 over anything, as long as it's greater than or equal to 2, and it's got to be an integer, which means 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, so just counting numbers basically. Then you could take this root here, provided that root exists. So what we're looking at here, just a general example. So say I've got 4 raised to the 1 over 4. Okay, that would be the same thing as the fourth root. It's important to put that root within this little kind of triangular area, or V area. So it's the same thing as the fourth root of 4. Okay. If you want another example of it, if I had 5 raised to the 1/8, it'd be the same thing as the 8th root of 5. Okay. 2 says a is a real number, and if m and n are integers containing no common factor with n greater than or equal to 2, then a raised to the m over n is the same thing as the nth root of a to the m, or the nth root of a, all raised to the n, m, provided that the nth root of a exists. Okay, a little bit of a tongue twister there. So for this one, so if I've got, I don't know, let's do something simple. Let's say 2 raised to the 5 over 4. Okay, I can rewrite that as the 4th root of 2 to the 5th. Or I could rewrite that as the 4th root of 2 raised to the 5th. And the reason we can the reason that switching these around might be helpful is that sometimes it's easier to simplify one way or the other. Sometimes it's easier to take the 4th root and then raise it to the 5th rather than raising it to the 5th and then taking the 4th root. Okay, especially if you're doing it by hand. Alright, next part, special binomial products. You should know this, it's full method and everything, how it simplifies. If you've got x plus a times x minus a, it simplifies to the difference of squares, which is x squared minus a squared. If you've got x plus a all squared, then you're essentially multiplying these insides. So you'll do x plus a times x plus a, which renders you x squared plus 2ax plus a squared, which is your perfect square trinomial. 3 says x minus a all squared, that simplifies to x squared minus 2ax plus a squared. That's also a perfect squared trinomial. I don't expect you to memorize these per se. You can FOIL them out if you want to. So if you get a problem like x plus 3 squared, I don't expect you to memorize this formula and be able to jump straight to this. If you need to take a second and FOIL it out and work it, that's perfectly fine with me. It's just a reminder that these properties are available and can make it easier if you know them. Okay. So another thing we're going to have to wind up doing here is some factoring, and then we'll get into the complex numbers. But I got a few examples here, and this is kind of where it comes into play of why I mentioned this above. Okay, these special binomial products. So if we want to factor 9x squared minus 25, what we can do, okay, we can notice that, okay, I've got my x squared here. 25 is a perfect square, 9 is a perfect square. So I could rewrite this as 3x parentheses squared minus 5 squared, because 5 squared is 25. Okay, so if you go up here, you've got a squared minus a squared. That looks like the difference of two squares right here. So if I wanted to rewrite it, what I could do is just rewrite it like this. So I could rewrite it as 3x minus 5, and then you're going to go up here and look at it and make sure you're right. So you got your minus one, or I'll write your plus one first so that we'll all have it all the same. That's why I wanted to reference it back to see which one will come first in the equation. So it doesn't matter really which one comes first, but we'll keep it consistent. And we got 3x minus 5. So we got 3x plus 5, 3x minus 5. If you don't believe it works, just FOIL it and kind of work backwards, and you'll see that it works. Alright, this one here, we've got 4x squared minus 12x plus 9. Okay, if we're looking at that one, we've got some perfect squares here. 4 is a perfect square, 9 is a perfect square. We wind up with a negative in the middle if I want to go back up here and kind of compare. So, got a perfect square here, and a minus in the middle. So I can see that what I might need to have here, if I can rewrite it, I can rewrite it as 2x squared minus 12x plus 3 squared. Now I'm going to show you two. Alright, so if you're looking at your formula and kind of comparing back and forth, right? So we've got a minus 2a here. Well, your a is whatever squared on your last term. So this middle term must need to be 2 times that a, right? So if I come down here, and I'm looking at it to see if it's going to work. Okay, so the hard part is here, our x is technically 2x. Okay, so that what we're looking at here is 2 times 3 times 2. Okay, if we wanted to break it up into that. So if you wanted to, you could replace that with 2 times 3 times 2, so that that perfect square trinomial works out a little bit better. But essentially what it turns out to be, because it's that negative one, you know what your 2's and everything are, you know what your x's are, is if we're going to write it backwards, it's just going to be the perfect square one. So you're going to have your x minus your a squared. So you're going to have 2x minus 3 squared. Now if that's not the easiest way for you to figure it out and you got another method, by all means go ahead and use your other method to solve it. There's several different ways of factoring, and if all else fails, you can always do the quadratic formula, which we'll probably eventually wind up going over again here soon. Okay, now if we look at this one, okay, this one, if I'm looking at it, my phone will stop going off. If I'm looking at it, this definitely isn't a perfect square on the front. Okay, so we're going to have to do a little extra work to factor it. Okay, like I said, if you've got a method of factoring that works for you, stick with it. As long as you're getting the right answers, I'm fine with it. Alright, so if you try to work on C, which I now have marked out, what you'll see is it doesn't factor. Okay, so I think I made a typo there. Honestly, can't remember what my initial one was that I was trying to go for there to make it factor, but it doesn't factor. So we're just going to skip it for now, move on to part D. Part D is 6x squared minus x minus 1. So what I'm going to do, so I could have a 6x here, I could have an x here, or I could have 3x and a 2, because those are the two factors of the x. So this is what I was taught as the guess and check method, essentially. If that's the method you like to use, go on ahead, be my guest, and use it. If you got another method, like I said, feel free to use it. I'll show a few different methods throughout the rest of the semester too. So, you know, if factoring is tough for you, hopefully you'll grasp onto one of them. Now, if I'm looking at it here, I got to figure out something. Well, what I also see is I need a factor that's going to multiply to give me 1 here. Well, only 1 times 1 is going to equal 1. So the only options I have left are, do I put a positive or a negative? Okay, it's going to be both, right? So one of them's got to be a positive, one of them's got to be a negative. We just got to figure out which one it is. We got to figure out, we basically have 4 options to choose from. So if we back work it, 6x times 6x is 6x squared. 6x times negative 1 is negative 6x. 1 times x is x. That's going to leave you with a negative 5x. So that doesn't work. And if you switch it, it also doesn't work. So you wind up with a positive 5x. Neither of those work. So we can already see that this first combination is not going to work out. So it's got to be a combination of here. I'm not sure if I got a positive here or negative here. So if I go 3x times 2x, that's 6x squared. 3x times negative 1, 2x times 1, those combined will give you that negative x, and 1 times negative 1 will give you the negative 1 that you need there. So the combination you need is a positive here and a negative here, so that your final answer looks like 3x plus 1 times 2x minus 1. Like I said, if you got a different method of figuring that out, by all means, feel free to do that. Now I'm going to show you a method with the next one that you might like, you might hate. So hang on just a second. Let me get the page formatted, giving me a little more space. Probably erase this, so go ahead and make sure you got this down. And I'm going to try to show you what's known as the X method. Alright, so you can see I erased that, just give me some more space. So if you need, you could write this on the side of your paper, you can write it wherever you want to, make space. You probably have more space than I had anyway, because I've got this big chunky marker I got to use on the screen. But either way, this is the X method, or this is what's called the X method. We got the big X here in the middle. We got AC on top, we got B on the bottom, and this is going to wind up being a fraction over A and a fraction over A. I'm going to show you step by step how it works. Now, I'm going to do it, we already did D, so I'm going to do it with E. So, in this one, whatever's in front of your X squared is your A. Whatever's in front of your X is your B, and your constants, your C. So if we did the X method with this one, A times C would be 10 times negative 5. Your B here is 23. Alright, and your A here is 10. So we have got the X method started out nicely. Now I'm going to change colors, kind of contrast so you can follow me. Now 10 times negative 5 is going to be negative 50. Okay. Now I need two factors of negative 50 that add to give me 23. Okay. So two factors of negative 50 that add to give me 23. Now, it might not seem that obvious at first, and if you need to list the factors out, you can. So, I mean, if you need to come over here to the side and list the factors out, okay, I've got 1 and 50. That gives me 50. I've got 2 and 25. Oh, look. 2 and 25. One of them's got to be negative to give me negative 50. So, if 2 is negative, then 25 minus 2 is 23. That works. So you got to keep the negatives on them. So I'm going to have a positive 25 and a negative 2. Those are my two factors. Okay. Now the key here comes in the simplification. So let's use that one. Okay. We have to simplify these fractions. So negative 2 over 10 simplifies to negative 1 over 5. Okay. And 25 over 10, what does that simplify to? So both are divisible by 5. 25 is divisible by 5 to give you 5. 10 is divisible by 5 to give you 2. Okay. Now, here's where this comes into play. So the way you do this, and watch closely, run out of colors, but alright, so the way, like I say, you do this, watch closely, and my marker's done disappeared on me. Technical difficulties I'm having tonight. You're going to write your parentheses, right? Okay. The way this works, you're going to start with the bottom. The bottom goes next to your x. So we got 2x plus 5. Next column, we are parentheses, we've got 5x minus 1. Okay. So we took this, we said 2x plus 5. 5x minus 1. To show you it works, 2x times 5x is your 10x squared. 2x times negative 1 is negative 2x. 5 times 5 is 25x. 25x minus that 2x is your 23x. 5 times negative 1 is 5. So, if you can do this x method here, you can solve this no problem. Like I said, some people really like the x method. Some people memorize the format AC over B with your A's on the bottom here on the sides. You have to simplify the fraction. If you don't simplify the fraction, it won't work. But if you simplify these fractions into their simplest terms, all you have to do is denominator goes on your x, numerator goes on your corresponding whole number here, and denominator goes on your x, and your numerator goes right there with your constant. So, simple as that. If you like the S method, use the X method. If you don't like the X method and you got another way of factoring that you're comfortable with, stick with it. Alright, complex numbers. The number ax plus bi in which a and b are real numbers is said to be a complex number in standard form. The a is the real part of the number, the bi is the imaginary part. If b equals 0, the number a plus bi equals a is a real number, and if b is not equal to 0, the number a plus bi is an imaginary number. If a equals 0, bi, which is what's left over, is a pure imaginary number. And that pretty much covers the review. Just to give you a few examples of these, I guess. So, what you can have here. So, for this one, if your a was, say, 5x, and then your b was, say, 4i. Okay, that would be an example of this in this form. Okay. Now, most of the time you're going to see it like in this form here. So maybe you'll see it as 3 plus 2i, or 3 minus 2i. That's possible as well. Sometimes you will see it like this, where you just have a bi. So you might just have like a 5i. Another thing that's often forgotten by people is I squared is the same thing as negative 1. Okay, so I is actually just the square root of 1, which we know we can't do, and have a real number, which is why we call it an imaginary number. So that covers your review for chapter 3. Like I said, hopefully you knew most of this stuff, or at least it gave you a little refresher of it. Now, head on over, get started on chapter 3.1.